This is a lesson video for 3-4 on angle bisectors after you've already gone over the warm-ups and after you've already checked your homework and turned it in. So we're going to construct angle bisectors. You've constructed things that bisect before with perpendicular bisectors. So you're going to grab a piece of patty paper, pause the video, and I want you to draw a large acute angle on the patty paper. Try drawing on the dull side, it's easier with your pencil. And then fold it and find that line of symmetry for your angle that would create the angle bisector by big idea before we work on constructing it with compass. So pause the video now and go do that. If you are back, you have a piece of patty paper in front of you where you've made that acute angle and you folded it to find the line of symmetry for the angle. That line of symmetry is the angle bisector. And so our next task is going to be to try to figure out how to get that by construction. We know where the line is already, so we want to study it and use its properties for construction. So it's a little bit like cutting out a heart. We cut out half of it so that when we opened it up, when you open up your folded patty paper on that line of symmetry, we have the full angle and that crease is the angle bisector. So here's where you want to do this on your patty paper, but then maybe put your patty paper into your notes later or sketch it into your notes later. So you would want to construct with your compass a circle at the vertex of your angle. So you can see in my picture that I've got this circle called circle V at the vertex or at the center. Okay, and that's what we need to start with your compass. So would you go ahead and do that? And again, pause the video where you need to. When you make that circle from your angle's vertex, you create two new points on your angle. You also create one on your angle bisector, but at the moment we're just going to focus on those two new points. And if I were to connect triangle ABV, the triangle I get should have two congruent sides from the two radii that I used to form those sides. So it's definitely an isosceles triangle. So ABV is isosceles. Yours might even be equilateral, but for certain it's isosceles. And angle V is our vertex angle. So what I know about isosceles triangles is from their vertex angle, they have a line of symmetry. So from this, and we don't have to draw this segment in, we can imagine that side. Triangle ABV's vertex angle being at V means if I could split it right down the middle, I could have my angle bisector in there. So what's true besides two angles being congruent at the bisector, because we know that it's going to fall and do that, is that in this particular case, because it's isosceles, this is also the perpendicular bisector of side AB. So in this case, only because the triangle is isosceles, the perpendicular bisector of side AB is the angle bisector of angle B. So we forced an isosceles triangle to be formed. And once that isosceles triangle is formed, we're going to use those two new points, AB, to do a perpendicular bisector, and that's going to be our plan for our construction. So the construction, here's what we know. If a point's on the bisector of the angle, then it's equidistant from the sides of the angle. Again, pause the video to get the properties down. So in order to do a construction, we have that plan from what we saw in our patty paper, was that if we could make an isosceles triangle, we could do the perpendicular bisector of its vertex angle, and that would be the angle bisector we seek. So I've got an angle here. We're going to try this out, and then we'll show you some steps. You can also rerun the video as much as you like. The first thing we did in our plan on patty paper was we swung a circle, and that circle was from the vertex of the angle we're trying to bisect. I'm not going to swing a full circle. I think I could just do an arc that bisects it twice in order to make that isosceles triangle that we made before. Knowing that the two new points we just created would be the base opposite the vertex angle. And if I did a perpendicular bisector between those 2 points, now keep in mind I already know one point on my angle bisector is my vertex, so I only need one more. So when you see the construction of perpendicular bisector, we usually use two. I'm only going to use one because I already have a point on the angle bisector. I have the vertex. So you can swing a full perpendicular bisector construction, or you can just swing one additional set of arcs to make one additional intersection in order to form that. And from my vertex out through that point of intersection, you've created your angle bisector. You can pause the video and put it back if you need to see that multiple times. You can also go to the construction website to see that again. So construction steps, if you're somebody who needs to write down steps, pause the video so that you have steps you can follow. And then the last thing we're going to do is we're going to come up with a plan for how to not only bisect angles, but use that to create additional things. We already know we can get 90-degree angles and 60-degree angles from constructing perpendiculars and equilateral triangles. So pause the video and try to come up with a plan for how you can use angles you know how to make and bisectors to come up with these 3 angles. Come back to the video once in your notes you've written out a plan or an idea for how to create an angle, bisect, or combine angles to make angles measuring these 3 specific values. Pause now. If you're back, why don't you compare some plans from previous years? For a 45-degree angle in the past, students have said make a perpendicular to get a 90-degree angle, bisect the 90-degree angle, and we'd have a 45. For 30, they've said our plan would be make an equilateral triangle and bisect one of the 60-degree angles to get a 30. But 105, I have had students come up with so many different plans that I listed several that they've come up with. So 105 degrees could be a 90-degree angle and a 15-degree angle combined together with angle duplication. And to get the 15, you could start with an equilateral, bisect to get a 30, an angle bisect a 30 to get a 15, and then combine the 2 to make an angle, but again, all by construction. I've had students say they would bisect a 90 to get a 45, and a 45 with a 60 combined together, angle duplication would be 105 degrees. And then I had a student who said, well, I'd make a 135, I'd bisect a 90, so I could put a 90 with a 45, and then take away a 30, which came from half an equilateral. So jot down a plan, and then you're going to pause the video and actually try to create these from what you've got, working with your table partners. This is not a do this all by yourself. Actually pause videos, look around, see who you can work with. When you come back, then we'll show you what it could have looked like. If you're back, I've got some constructions up here that mimic what you were going for. So the 45, you see the perpendicular bisector construction. Okay, and that's right here, as well as the equidistance points they started from to get the 90. And then these 2 are from their angle bisector construction. Okay, same for 30. There's an equilateral triangle construction first with that vertex of it R, and then an angle bisector construction. Okay, and I'm not sure what this extra arc in here is for, so let's just ignore it. And then on the 105, again, took a 45 from my beginning, took a 60 from my middle, and put them together in order to get 105. And on homework, it's totally fine if in one problem you constructed a 60, that if you want to use it again in another problem, you just duplicate it right off your homework page as long as it's the same homework assignment. So these are your tasks, and this is due Monday.